I started. It's Monday. All right, first question. Very simple, just testing if you know your trig rules. By the way, here's the trig rules. A way I help to remember it is I know sine and cosine. Let's say you start off with that. Let's say you just learned that one. If you notice, all the cos ends with a co. So all the cos end with a co. So I look at this one, and I say, oh, if it's cosecant, I know it has to be the other two, like cosecant, cotangent. Like, because they're cos. Which means secant can't be that, right? So it's secant tangent. Also notice all the cos end up with a negative. So that's another way to help you remember it. And then this is like its own unit. So I try to think of it as like 3 groups instead of like 6 individual things. That might help you remember it. If not, just find a TikTok that I don't know or something like that. All right, next part. The first question is just basically going to be, hey, do you know your trig rules? Let's do like 6 tangent x minus 4 secant x, something like that. So if you know your tangent rules or your tangent derivatives, the coefficient does not affect the derivative itself, so 6 just stays in the front. Then you derive the tang, which is just going to be secant squared. I know it's not the cosecant squared because it's not co. Minus here, the 4 again will not affect the thing. And the secant, the derivative of secant is secant tan. So the first question is basically, for me at least, is to see, do you know your trig? Second question, can you do a trig with a product rule? So let's say, no, let's do it like that. Let's just do x to the 4th times tangent x. Okay? So this one's the product rule using trig rule, which means to help identify this is f and this is g. Product rule is g f prime plus f g prime. So it always helps to identify it if you need to. If you don't need to identify it, you're not forced to identify it. X to the 4th, the derivative of x to the 4th is 4x to the 3rd. Tan x, the derivative of tan x is secant squared x.
What number is this?
I'm making it based off the test. So then it is tan, because it's tan x, g, times 4x third plus f, which is x to the 4th, times secant squared x. Not much you could do to help it out, so I'm just going to rewrite it, and then just to make it a little nicer, but that'll be it. Basically testing if you remember your product rule from yesterday, or from last quiz, and you know your tangent, your trigs. Okay. I'm going to move on to the next one. Next one is just a practice of a chain rule. So let's do like 6x to the 3rd plus 17 all to the 10th power.
Question.
Yeah.
For the x to the 4 times x squared x, there should be another parenthesis.
This could technically have parentheses.
Not there, on the other side.
Oh, you're right. I forgot that one. Okay. For this one, 6x to the 3rd plus 17 is 10th power. This is a basic chain rule one. So I take the 10th power, move it to the front. My derivative is kind of like f is my 10th power, while my g is the inside. And chain rule is f of g prime. Oh, I'm sorry. Wrong way. F prime of my g times g prime. So f prime is a variable or exponent to 10, so I bring the 10 down. Then I do the inside, which stays exactly the same, untouched. We reduce it by 1, so that's a 9, times the derivative of the inside. So I take the derivative of this part right here, which should be just 18x squared. Because these are single terms, they'll be nice to combine them. 180x squared, 6x to the third plus 17 to the ninth power. Okay. So with chain rule, you could have a chain rule like this. The square root of x to the fourth plus 3. In this case, you need to recognize this square root. I have to rewrite it to something I can work with. So I'm going to rewrite it as x to the fourth plus 3 to the half power. If I rewrite it like that, then I can just use the chain rule I used previously. I'm going to bring this one down, the half power. The inside is untouched. The exponent has been reduced by 1, so it's a negative half power. And then the derivative of the inside is 4x to the third. Let's rewrite that nicely. Since 4x to the third is on top, is 4x to the third. It's 1 over 2, so 2 is on the bottom. And this is a negative exponent, so I'm going to move this to the bottom. As I said, I recanted my statement. You don't have to remake it to the square root, but I do not want negative exponents, so I would say at least move it to the bottom. But you can leave it as a half power. And here, there is actually something you can simplify, the 4 and the 2. So just make sure, don't forget that. I'll take a half point if you do. Yeah.
Half point meaning half.
Half of
Like
all the
half
points you
of
could.
five or half of like 25, which is really like 2.
I got a 25. It's only course.
So it's really like 2 good.
I guess so, yeah. There's only like there's only 5 questions on this quiz. Yeah, so. All right. So don't think of it as, oh, if I get one wrong, I get an 80. You got to think of it as, I only need to get 5 right to get 100.
Definitely one wrong.
Why is it
5 questions on the quiz.
so much we need to remember for one quiz?
Imagine it was one big test. Yeah.
Aren't we having that?
Yeah,
every
that's
year?
happening.
Yeah, that is happening. You don't have to imagine that far, but
Yeah. Wait, when is that?
I should know what you
that'll be right before Hanukkah, which is 15th.
Can you just give us like the size of the roads?
No.
Like, why do we really need to memorize that?
Yeah. All right. Next one. Now we did trig and we did chain. So let's put that together. Trig and chain. Or chain trig, yeah. Let's do cosine of 7x to the fourth power minus 2. So in this case, the outside is the cosine. So that's going to be my f in the chain rule. While the inside is going to be the 7x to the fourth minus 2.
Oh, it's a chain rule?
So it's a chain rule
Why
and a
not
trig
just
rule.
valid?
What?
But there's some valid.
You're right. Chain rule doesn't always have to be in the power. In this case, it's inside a trig. So that's another reason that could cause chain rule.
Chain rule is just.
It's not only just powers. We just usually use powers because it's easy to see. So, cosine of this. Remember, chain rule is f prime of g times g prime. So I need the prime of cosine. So the prime of cosine is negative sine. The inside goes untouched. So it should say exactly the same. 7x to the fourth minus 2. Good, but times, not minus, but times 28x to the third. There's nothing you could really simplify. If you left like this, you would get full credit. I would just rewrite it like this. But you would get full credit here because there's nothing much you could do actually. Sine 7x to the fourth minus 2. Let's just do one more of these.
Can you do it where it's double?
Exactly. So what do you mean double? Like the trig is to become two things?
Yeah.
Perfect, that's what I was going to do. So let's do it with cosecant. No, let's do it with secant. So secant of 6x squared plus 3 again, a chain rule of trig, but this is the f and this is the g. So I need a derivative of secant. Now the derivative of secant is secant x tan x, which means when I derive this, I'm going to write secant with a parentheses and tan with a parentheses, and within both parentheses, we'll have the original 6x squared plus 3, 6x squared plus 3. So if it splits into 2, it still has the original. Just think about it in the normal way. Secant x becomes secant x tan x. That x became 2 x's. Same thing here. Now the derivative inside, even though you see 2 as a result, you only do it once. So 12x and then you can just move it. And then you just move it to the front.
Or you can see it.
Double chain? What do you mean? You will not do it again unless I ask for the second
No,
part.
I'm saying like times
12 bucks, yeah. Yeah. So you can put it in the back or the front, doesn't matter.
Can you do it with double chain?
Give me an example. What do you mean by
Like
that?
where the parentheses square.
Oh, yeah, sure. We could do that. So, let me think if I could do it.
X plus 5, right? This is power minus 1, all that.
All right, let's do that.
No, it's
Oh,
something
we did
different.
that one yesterday.
Yeah.
5.
Eight up to 5.
Try 3x to the fourth plus 2 to the fourth power minus 1 to the fifth power. I have to put this minus 1 here just because if I didn't put the minus 1, you could actually just do fifth power times the fourth power is the 20th power and just do a single one. So I purposely put the minus 1 there for a reason.
You like one line.
Just to prevent you from doing the shortcut, basically. To like test the actual skill you're asking, which is chain and chain. Okay. So first let's identify our, let's say our primary or the grandparent or the master F and G. So this is the master F and this is the master G. So this whole thing within the 5 power is the G.
We're going to do 5 times
So 5 times the untouched inside.
3x.
Yep. 3x to the fourth plus 2, parentheses to the fourth power, minus 1. A bigger parenthesis here. And that to the fourth power. Now we need the derivative of the inside here. So I'm going to put it as a sidebar.
So aren't you going to multiply?
So 3x to the fourth plus 2. Yeah, you're going to multiply the inside, the next derivative. But 3x to the fourth power minus 1.
So it's going to be 4 times 3x to the 4th plus 2.
Mm-hmm. Good, because this is our new F. This is our new G. So this one would be on the as a sidebar. 4 3x to the fourth plus 2 to the third power. This minus 1, the derivative of minus 1 is 0, so that disappears. Times the derivative of the inside here, which is 12x to the third. So that whole thing is the derivative of the green, or the G, the original G. I could put well, I'll just write it like this first. So 4, 3x to the fourth, 3x to the fourth plus 2 to the third power times 12x to the third power. Yeah, multiply 5, 4, 12 of them. That one you will, because those are actual numbers. You can
40?
20, and then 12 is 240. So 240, I'll put the x to the third in front, and then all this. Plus 2. Times. That'll be it. All right, that covers your quiz. It looks messy, but there's nothing you can really keep going with, so.